This single circuit scares most class 12 students. Multiple loops, multiple currents, Kirchhoff's law everywhere. But don't worry. By the end of this video, this diagram will feel easy and logical. Welcome to the first video in our problem-solving series on the current electricity chapter of Class 12 Physics. Now let us find the current in each limb of the circuit. First, we assume the directions of currents as shown in the circuit diagram. Current I1 flows through limb AC. Current I2 flows through limb AB. Current I3 flows out of the battery on the right side. These directions are assumed. If any current comes out to be negative, it means the actual direction is opposite. Using these assumed directions, we will calculate the currents in all limbs using Kirchhoff's current law. If you are not confident with Kirchhoff's laws, I recommend watching my short 10-minute video on this channel that explains the laws clearly. Now let us apply KCL at node A. From the circuit diagram, current I1 is entering node A. Current I2 is leaving node A. Let us assume an unknown current IA is also leaving node A. According to Kirchhoff's current law, the total current entering a node is equal to the total current leaving the node. So at node A, current entering is I1 and currents leaving are I2 and IA. Therefore, we can write I1 equals I2 plus IA. Rearranging this equation, we get IA equals I1 minus I2. Using the same logic, let us now apply KCL at node B. From the circuit diagram, current IB leaves node B. Currents I2 and I3 are entering node B. According to Kirchhoff's current law, the total current entering a node is equal to the total current leaving the node. So at node B, we can write IB equals I2 plus I3. Now let us apply KCL at node C. At node C, the current entering the node is I2 plus I3. Current I1 is leaving node C. Let us assume an additional current IC is also leaving node C. Applying KCL at node C, we get I2 plus I3 equals I1 plus IC. Rearranging this equation, we obtain IC equals I2 plus I3 minus I1. With this, we now have all the currents in the circuit expressed in terms of I1, I2 and I3. The next step is to calculate the values of I1, I2 and I3 using Kirchhoff's voltage law in the loops. Now let us apply Kirchhoff's voltage law in loop ADCA. First, we assume that any voltage drop occurring in the direction of the arrow is taken as positive. Now follow the blue dot as it moves along the loop. We will note the voltage changes as it passes through each circuit element. The voltage drop across the 4 ohm resistor is written as 4 multiplied by I1 minus I2. Next, the voltage drop across the 2 ohm resistor is written as minus 2 multiplied by I2 plus I3 minus I1. This term is negative because the assumed positive direction is opposite to the direction of current. Next, the voltage drop across the 1 ohm resistor is written as 1 multiplied by I1. Next, we write minus 10 volts. This is because we are assuming voltage drops as positive and this battery causes a voltage rise. This completes the loop. According to Kirchhoff's voltage law, the algebraic sum of all voltage changes in a closed loop is 0. So we equate the entire equation to 0. Now we collect all the terms containing I1, I2 and I3. After simplifying, we obtain equation 1. Now let us apply the same method for loop ABCA. First, we follow the arrow direction. Any voltage drop in the direction of the arrow is taken as positive. Now start following the blue dot as we write the KVL equation. The voltage drop across the 4 ohm resistor is written as 4 multiplied by I2. The voltage drop across the 2 ohm resistor is written as 2 multiplied by I2 plus I3. The voltage drop across the 1 ohm resistor is written as 1 multiplied by I1. Again, a negative sign is added here. This is because the battery causes a voltage rise and we are assuming voltage drops as positive. This completes the loop. According to Kirchhoff's voltage law, the algebraic sum of all voltage changes in a closed loop is equal to 0. So we equate the entire equation to 0. Now we group all the terms containing I1, I2 and I3. After simplifying, we finally arrive at equation 2, as shown. Finally, let us apply Kirchhoff's voltage law in the loop on the right side. We will follow the same assumption. Any voltage drop in the direction of the arrow is taken as positive. Now follow the blue dot and keep writing the KVL equation. The voltage drop across the first 2 ohm resistor is written as 2 multiplied by I2 plus I3. The voltage drop across the second 2 ohm resistor is written as 2 multiplied by I2 plus I3 minus I1. Finally, we write minus 5 volts. This is because the battery causes a voltage rise in the direction of the arrow. This completes the loop. According to Kirchhoff's voltage law, the algebraic sum of all voltage changes in a closed loop is equal to 0. So we equate the equation to 0. Now we collect all the terms containing I1, I2 and I3. After simplifying, we obtain equation 3. We now have 3 simultaneous linear equations with 3 variables, I1, I2 and I3. We will now solve these 3 equations. First, multiply equation 2 by 2 and add it to equation 3. After simplifying, we obtain equation 4. Please go through the equation shown on the screen. Now we will multiply equation 2 by 7 and subtract it from equation 1. That is, 7 times equation 2 is subtracted from equation 1. After simplifying, we obtain equation 5. Now subtract equation 4 from equation 5 and solve the resulting equation to obtain the value of I2. Now substitute this value of I2 into equation 4 and obtain the value of I3 as shown on the screen. Now substitute the values of I2 and I3 into equation 3 and obtain the value of I1. We now have the values of I1, I2 and I3 as shown on the screen. Now let us start calculating the current in each limb. We know that the current in limb AB is I2. From our earlier calculation, I2 is equal to 5 by 8 ampere. The current in limb BC is I2 plus I3. This calculation is shown on the screen. After solving, the current in limb BC is equal to 2.5 ampere. The current in limb CD is I2 plus I3 minus I1. After substituting the values, we obtain 0 ampere as shown on the screen. Finally, the current in limb AD is I1 minus I2. After substituting the values, this is equal to 15 by 8 ampere. Thank you for watching this video. If you found it helpful, please like and share this video with your friends and classmates. Do subscribe to the channel for more Class 12 Physics problem-solving videos. In the next video, we will understand and solve NCERT exercise problem 3.7 from the current electricity chapter. See you in the next video.